Welcome, students. Today we are going to learn about how to solve an equation for a variable. And you probably thought, well, I've done that before. You will be able to solve an equation with more than one variable for the indicated variable. So the equations we're going to solve today will have more than one variable in them. All right, the distance formula says that distance equals rate times time. So distance equals rate multiplied to time. So what if a runner wanted to find the rate he or she was going during a race? All right, so what we want to do here is I'm going to write down steps. I want you to write these in your notes. Steps for solving these equations. Okay, step one is underline the variable that you are solving for. So we want to solve for rate. We want rate by itself. So what I'm going to do is underline rate. Next, we're going to do the order of operations backwards. So I want R by itself, but there's a T multiplying it. So what I need to do is divide both sides by T to move this T away. So I'm going to go like this and go like this. These T's cancel to ones. My R is left. Then I bring down D over T. Lastly, simplify if possible. And we cannot simplify here because D over T is as low as it goes. So now what I did was I solved for R. So rate equals distance divided by time. I was able to move things away from R. Now I can use my new formula to solve this question. This runner won the Twin Cities Marathon in 2007. He ran 26.2 miles, that's our distance, in approximately 2.25 hours. Use this formula to find his average speed, which would be our rate. So all I have to do is take 26.2 and put it where the distance is, and then take the time and put it underneath 2.25. Now I can divide. When I divide, I get 11.64 miles per hour. Now it says round to the nearest tenth, so what I'm going to do is get rid of this. So 11.6 miles per hour. Wow, that's pretty fast. Okay, a little math joke. Why did the variable add its opposite? Okay, so bring your answer to class and we'll see if you get it right. Why did the variable add its opposite? This flowchart can help us solve any equation. It will help us with some of these more complex ones. Can you use the distributive property? And if you can do the distributive property, then you should do it. Can you combine like terms? If you can, you should do it. Are there variables on both sides? If there are variables on both sides, you have to move them all to one side. Then, once you do all of this simplifying, then you can do order of operations backwards, which is usually add or subtract, then multiply, divide, and then check your answer to make sure it works. Alright, so our first one. These equations that have more than one variable are called literal equations. That's what that means. It means an equation that has more than one variable, and sure enough, this has an variable m, and variable n. We want to solve for variable m, so I'm going to underline it. Then, just like any equation, I say to myself, what is on the same side of the railroad tracks as this variable? And I see a minus n. So I need to move that. How do I get rid of a minus n? Well, I plus n. But watch what happens when I do this. This cancels, the m comes down, and what I'll do is I'll take this 5 and bring this down, and then I'll just say plus n, because I don't know what n equals. So there's my answer. M equals 5 plus n. My next equation is m divided by k equals x. And we want to solve for k. This is tricky, and we have not dealt with this very often. Whenever the variable you want to solve for is in the denominator, you need to get it out of there. You remember we talked about the weirdo in the basement? You don't want your variable to be the weirdo in the basement. That's a bad thing. So you need to get this variable out of the basement in order to solve this. And here's how you do it. If it's dividing by k, you need to multiply both sides by k. This will cancel, and the m is on the left, and then I have x multiplied to k. I have this right here. Now, I still need k by itself. So, how do I get rid of this x that's multiplying? How do I get rid of it? I divide. I divide by x. This will cancel. Now I have k equals m over x. I'm done. That's it. So in a way, sometimes kids like these equations because they don't have to get an answer. They don't have to get 17.25. They can just move stuff and then say they're done. We move stuff and k is by itself and this is done. Alright, this is a very common use for this skill. Is you have a formula and you want to use the formula to find something other than what it's written for. A good example is the formula for Fahrenheit temperature in terms of degrees Celsius. So here's Fahrenheit. If you know what your Celsius temperature is, you can multiply it to 9/5, add 32, and you'll get your Fahrenheit temperature. Well, they want you to solve for C. They want you to get C by itself so that you can use this formula the other way to find Celsius instead of Fahrenheit. So, let's follow our steps. Underline the variable we want. Next, I'm going to do the order of operations backwards. Well, I see that this 9/5 is multiplying to C, and this 32 is adding to C. So I'm going to do order of operations backwards. I'm going to minus 32 from both sides. So I minus 32, and when I do that, there's my railroad tracks. This cancels. On this side here, I'm going to write that nicer. I'm going to write F minus 32. Okay? Then I'm going to bring down what I have. I have 9/5 multiplied to C. Do you remember how we solve if a fraction is multiplying our variable? Do you remember what we do? We multiply by the reciprocal. So we're going to multiply by 5 over 9. So I'm going to multiply by 5 over 9. This will cancel. 5 goes into itself once. 9 goes into itself once. And I get C by itself. That's what I wanted. I wanted that. Please look at the left side and listen to what I say here. So the 5/9 is multiplying over here. It's important that we put a parenthesis on this. So now you can leave it like this. We can say 5/9 multiplied to F minus 32. If you want to distribute, you could. Otherwise, we can leave it like this. C is by itself. Everything's on the left. All right, practice problems. We want, on this one, do this on your sheet, you want to solve for x. So you need to move this 2, and you have to get rid of the 2 by dividing. So you have to divide this entire side by 2. Here, you want the v, and because it's in the basement, get it out of the basement, and then move the d away from it. So, and lastly, you have this equation, and they want I by itself. So give that a try. Bring questions you have to class next time we meet. Take care.